Okay, so let's talk about the next part here. And the factor theorem actually goes very, very closely with what we've just done before. You'll often get a question that combines this all together. So we just looked at how to do this basically. Okay, so if somebody said take this and divide it by x minus 2, we would generate that part there. Okay. So what can we do? Well, we can see that x minus 2 is a factor of all of this. How do we know it's a factor? Because it divided cleanly, there's no remainder, and we're being told by this equation here. What would happen if x is 2? So x minus 2 is a factor. What happens if we just substitute in x equals 2? Have a quick go for yourself on the left-hand side of the equation and also the right-hand side for the equation. And what do you notice? Well, hopefully you spotted on the right-hand side, 2 minus 2 is going to mean it's 0 and you're multiplying by 0. So the right-hand side will be 0. But interestingly, and perhaps less obviously, the left-hand side will be 0 as well. This is essentially the factor theorem that you're seeing. So what does the factor theorem say? Well, it says if you have an algebraic factor, so I'm going to call this like an algebraic factor, x minus 2, it says if you have x minus a, it will mean that a is in like an actual number that you can just substitute in, a is a factor. So in other words, if I say to you x, let's say x minus 4 is an algebraic factor, well, that will mean that 4 is a factor. If I said x plus 6 is an algebraic factor, that will mean the numerical factor would be minus 6. The reason why is because you can write this as this, okay? Minus 6, and it still works. More formally, it's sort of written below, okay? So they use p here and f of p. F of p means you substitute in the number, doesn't it? In other words, you make all of the x's that value. Yeah? You should get 0. And it works both ways around. And you might not know it, but you've actually seen this before. Remember when you were working with quadratics, if I told you that number there was 1 and that number there was 5, you would have told me, well, if 1 is a root, that means that x minus 1 is one of the algebraic factors. If 5 is a root, then x minus 5, etc. And remember, you could work this backwards to find a quadratic like this. So really, you were kind of using the factor theorem there as well. So a couple of quick examples. What is the remainder when x squared minus 3x plus 2 is divided by x minus 2? Now, it would be very tempting from the lesson before to just sort of do our long division, but I was just checking there. We're actually not going to do that. The factor theorem says, it says, if I am told that something like this is a factor, well, I can just substitute in, p. So, sorry, that's the factor theorem. Well, the remainder theorem is really pretty much exactly the same thing. So if you want to know what the remainder is when you divide something, or if something is a factor, instead of dividing it algebraically, what you can do is you can just say, well, that says x minus 2, so that means that the numerical way of doing that is just substituting 2 into each of these x's. So let's have a look. If you substitute 2 into each of the x's, and that's the formal way of writing it, f of 2, you'll get 2 squared. Hopefully you can see this is just what's on the top, minus 3 lots of 2, plus 2 is 0. So what's interesting about that? Well, there's no remainder. If something has no remainder, it means it's a factor, okay? So a couple of different things going on there, but the main idea is if we want to know if something is a factor or if something has a remainder, Okay, we can use this factor theorem, and the remainder theorem is very much the same idea. That instead of doing algebraic long division, we can just take sort of the opposite sign here, and substitute it in. Let's do another one. What about x cubed plus 2x divided by x plus 3? Now again, we could, if we really wanted to, we could do x cubed plus 0x squared plus 2x, and we could divide it by x plus 3. It's going to take you a long time though. The quick way is, well, what's the opposite of plus 3? It's minus 3. So we'll just do minus 3 cubed plus 2 lots of minus 3. And you write out clearly that you're doing that substitution, and we get the answer. Remember, if the answer is 0, it will be a factor. If it's not 0, it means it doesn't cleanly divide. There'll be a remainder. So here we can see that there is a remainder. Okay? And if you follow all of this stuff here and you work through, you'd get minus 33 as well. Okay, so these boxes doing. So what's the remainder, for example, when x cubed minus x is divided by x plus 1? Well, the quick way of doing it is you would just put minus 1 in. The answer here is 0. What does that mean? It means that it's a factor. What's remainder when x squared plus 1 is divided by 2x minus 1? So we can make it more complicated if we want to. Okay, so what's the same as this? Well, 2x minus 1 in a bracket, if you remember, perhaps when you were solving from before, if you put this equal to 0, this is going to be 2x equals 1, x equals a half. So you can put in a half instead. What's x squared minus x when it's divided by 3x plus 4? Well, again, the same idea. You know, take away 4, divide by 3. Okay, you would substitute in that value. So some examples from the textbook. And the important thing here is the language for exam questions, because this is exactly what they say in exam questions. So show that x minus 2 is a factor. So what do we need to do? Well, hopefully now you know we need to put 2 in. If it's a factor, we want to show that the remainder is 0. But notice the extra part of the working out. So this bit here, you probably all worked out. You must say this other part here for the second mark. If if we put 2 in and we get an answer of 0, that must mean that x minus 2 is a factor. So this second line here is showing that you understand the factor theorem, the factor and remainder theorem. Okay? You need this extra part here. You need something like f of 2 equals 0 means x minus 2 is a factor. Okay, if you don't have that, you will not get the second mark. Fully factorize for this one here. What's different here is they're not telling you what a factor is. They don't give you any ideas, but we can pick some numbers. For example, if I pick 1 and I show that f of 1 is 0, that would mean that x minus 1 will be one of the algebraic factors, and that would let me factorize. Factorize just means put it all into factors. But you're going to need to check these with a calculator. So the advice is to pick some values, normally between sort of -2 to 2 or something like that, and you should find a value that will give you 0. When you do that, you can get an algebraic factor. And then what can you do when you have an algebraic factor? Well, perhaps the best thing to do here would be to take this and then to do a long division, and that will let you find the other part. So if you do f of 1, it doesn't work. F of -1 doesn't work. F of 3 works. You don't necessarily have to use f of 3, by the way. You might find another one. It's fine. You can do it by finding the 2 other factors as well. So when you know f of 3 is 0, that means x minus 3 is a factor. And that will mean that you can write this very, very long thing as x minus 3. And this other part, you will probably get this from the lesson from before. And in fact, I'm going to recommend you do it that way, just because that's how the exam question tends to go. This tends to be sort of like a part 1, and then this tends to be a part 2. They normally want you to use factor theorem in the first part, and then to use the long division in the second part. Just a final note, it does say factorize, so the quadratic should actually be broken up as well and factorized also. Yeah, that question there on the board is a very good illustration of what the questions look like. So pause the video here, have a quick go. Now, use the factor theorem. Use the factor theorem. Unfortunately, if you have done polynomial long division, you have not got the marks. Use the factor theorem means you must. It's not optional. You must, okay, use the factor theorem here. If you don't, you will not get any marks for this 2-mark question. When you put -2 in, you get 0. That's the first mark. This sort of so x plus 2 is a factor is a little bit weak, but that's your second mark, okay? Factorize completely. So the first bit of credit would be noticing, well, it's the same thing. So you know that x plus 2 is there already. Then there'll be some long division. You'll get this one here. And finally, you'll break that up into 2 parts as well. Okay. So factor theorem and remainder theorem, I kind of put these ideas in together because really they're sort of the same. The idea was that if you want to divide by x minus a, you can just do f of a, okay? And it works also the other way around. Remember that when f of a is 0, this means you have a factor, and this is when we talk about the factor theorem, okay? When f of a is not equal to 0, people will talk about there being a remainder, and you can refer to it as the remainder theorem.